Hello students, good morning, good evening and good night. Depending on which time you are going to observe this lecture. Welcome to this lecture. In this lecture we are going to discuss again a very important topic in your redox reaction chapter. So far in different lectures we have discussed many aspects of this chapter. In first lecture we have discussed about the preliminary idea, classical idea of the oxidation and reduction. And second we have discussed the correlation between the electron transfer with the oxidation and reduction reaction. And you know that oxidation is the process where there is a release of electrons. Reduction is the process where there is an acceptance of that electron. And we also know the oxidizing agent and reducing agent. And how do we correlate with this oxidizing agent and reducing agent with the oxidation number that we have discussed in lecture number 3. In the lecture number 4 we have discussed some very important questions that will give you the clarity about the concept of this oxidation and reductions. And in this lecture we are again very important topic that we are going to discuss, that is the types of redox reactions. So heading of this lecture is types of redox reaction. We already know what is redox reaction, or how this word redox word has been framed. That is basically comes from the reduction and oxidations, because in the reactions where the redox means the reduction and oxidation, both the process has been carried out simultaneously. That is why it is called the redox reaction. And there are basically 4 types of redox reactions that we are going to discuss in detail. This is K.K. Mukherjee, the Science with Mukherjee YouTube channel. So what are the classifications of the redox reaction? Let us understand. Redox reactions are classified in 4 ways. First, that is combination redox reaction. Second, that we are going to discuss, that is the decomposition redox reaction. Third, that is the displacement redox reaction. And fourth one, that is the dissociation. So these are basically the 4 types of the redox reaction. First one combination, second one decomposition, third one that is displacement, and fourth one the disproportionation reactions. So we are going to understand individually of these types of redox reactions. The combination redox reaction can be represented by this A plus B, it will going to create C. It is basically that redox reaction where that 2 molecules or 2 atoms are combined and it is going to produce a third molecules. And here A and B, that is going to give that C molecules. The main condition of this redox reaction as both or one of the reactant species, that is A or B, will be at the elemental stage. So A or B must be in the elemental stage. That is the first criteria of this combination, elemental elementary mental stage. Elemental stage. Elemental stage means that is in the molecular state, that is in the uncombined state, or you can say the free state. This is the combination reactions. And what is the example? Let us understand one example, that is carbon plus oxygen. It will going to produce the carbon dioxide. Very common equation. So here you can see the carbon having the zero oxidation number because it is in the elemental stage, and the oxygen also here is the elemental stage, and this has been probably going to produce the carbon dioxide which is in the combined state, and you will observe the oxidation number of carbon is 4 and oxidation number of oxygen is 2. So here what we find? We find very interesting thing that carbon is oxidized to the here to the carbon dioxide, and oxygen is oxidized to the carbon dioxide. So here you can see that both the component has been oxidized and one component is reduced. Here carbon is oxidized because we know in the oxidation there is a liberation of the electron, but here the liberation is not there because in the covalent compound there is shifting of the electron. It has been assumed. So here you can see carbon is oxidized, and you can write this oxidized. It is oxidized, and the oxygen is reduced because the oxidation number is decreasing. So we can say this, that is and here it is combination reaction because both are in the elemental stage. Another important reaction that we can observe, that is a CH4 plus O2. Here you can see one reacting species is the elemental stage and other at the not in the elemental stage. It is a combined state, that is measure, and it is going to produce the carbon dioxide and H2O. And you can observe here carbon having the oxidation number is -4, whereas it has oxidation number increased to +4 here. So you can understand that methane is oxidized here. Methane is oxidized whereas the carbon is reduced because carbon oxidation number is 0 and carbon oxygen element has the oxidation number 0 and it decreases to -2. So you can observe here the combination reaction. So what is combination reaction? It is basically the combination of the two element or one element or other in the compound. That is the reaction between them will be a combination reaction, and at the time we understand that both the components, one is oxidized and other is reduced. This is the combination reactions. So now we are going to discuss the decomposition reaction. What is decomposition reaction? In decomposition reaction, you will observe one thing, that molecule has been broken into two or more components, and one of the main condition for the decomposition reaction is that one of those components will be in the elemental stage. As we are in the combination reaction, both the reacting species will be, both or one of them will be in the elemental stage. In the same way, in the decomposition reaction, you can observe, you have to see, otherwise this will not be the decomposition reaction. One of the produced has been in the elemental stage. As for so we can write here the decomposition reaction is basically, it is the formation of the two components from a molecule. A molecule has been broken into the two or more components. So example of the decomposition reaction is, that is a very simple reaction, that is H2O created the H2 plus O2. In this case, you will observe the both the elements of the compound that has been carrying out this decomposition reaction will be either oxidized or reduced. Both the one component will be oxidized and other component will be reduced. That you can see here. This is here, that is +1. Hydrogen has oxidation of +1, and when it has been decomposed, after undergoing the decomposition redox reaction, its oxidation number is 0, hydrogen oxide 0, and the oxygen is also 0. So what we observe? We observe that in the oxygen, that its oxidation number will go to increase. So here oxygen is oxidized and hydrogen is reduced because oxidation number of hydrogen has decreases. So this is one of the very important decomposition reactions. And then another example that we can cite, that is KClO4 with KClO3 is decomposited into the KCl and 3O2, and it will be balanced this. So here you can see also that KCl, here Cl as the oxidation number is +5, right? And here the -1, the Cl in the KCl, the Cl has the oxidation of -1, whereas here this is oxidation number of the in oxygen in the KCl is -2 and it is B0. So what we understand, that this here the component oxygen is reduced and Cl, the oxygen is oxidized and Cl is reduced. So after reduce means decrease of the oxidation number. Oxidized means that in this case that the oxidation number will be increased. That is what we see, -2 to 0 and +5 to -1. So this is the decomposition reactions, redox reactions. One question normally comes, that is a decomposition and calcium carbonate, that is CaO plus CO2. Do you call this is a decomposition reaction, redox reaction? No, because here you can see both of the produced, the molecule has been broken into the parts, but both of the molecules we will find not in the elemental stage. CO is a compound, CO2 is also compound, so they are not elemental stage. That is why we will not call it is a decomposition redox reaction. You can also verify from their oxidation number also, that this oxidation number +2, here also you can see +2, this is -2, here this is -2, here you will this +4 and it is +4. So there is also, you can say, by calculating the oxidation number, you can say that there is no change in the oxidation number. So when there is no change in oxidation number, and there is no question of the redox reaction. So this is not the redox reaction. Now we are going to discuss the very important type of reaction, that is the displacement reaction. What is displacement reaction? This can be expressed like this, x plus yz, that will produce xz plus y. So what you can see, that one of the element of a compound has been replaced by another atom. It may be ions, it may be atoms, or replacing agent will be atoms of ions. So here you can see y is replaced by x. Y is replaced by x. That is why it is a displacement. It is displacing. The X is displacing what? Y in the YZ compound. So this is a displacement reaction, and displacement reaction is again be classified into two ways. One is the metal displacement. One is metal displacement reaction, and another is non-metal displacement reaction. Non-metal displacement reaction. So there is a two types of displacement reaction. You can see one is metal displacement and another is non-metal. Now we are going to discuss in detail of all these two reactions. First we are going to discuss the metal displacement reaction. Metal displacement reaction. Metal displacement reaction, in this reaction what we find, one reactive metal, active metal will displace the another less active metal from its solution. As for example, Zn plus CuSO4. Here you can find that Zn has replaced the copper from its solution and it goes to the solution itself. So you can see this is the reaction, ZnCu4 and Cu metal. Here you can see that copper is reduced. Reducing agent is zinc. Zinc has the ability to liberate electrons more easily than the copper, and that is why this type of reaction you can see. And this copper is replaced by the zinc. That is why it is called a metal displacement reaction. So here what is happened? Zinc is oxidized. Zinc is oxidized to Zn1 because zinc has oxidation number 0, and when it go to the Zn1 it is +2. The increase of the oxidation number means there is oxidation. And here you can see copper has the oxidation of +2 and it is been reduced to the copper reaction, and this is a reduction reaction. So this is the example of the metal displacement reaction. Another very important reaction we can see aluminium and chromium oxide. Here you can see the aluminium displaces the chromium. Here you can see aluminium 0 and it is having the +3. So it is oxidized. Aluminium here is oxidized, but it acts as a reducing agent. It reduces the chromium from this oxide. This is a very, very important reaction that you can observe when you are in the metallurgy section. At that time you see how the metal has been extracted from this oxide, and this is very important reaction. And here you can see chromium has been reduced. So what is going to happen? This is their metal displacement reactions. Now we are going to discuss the non-metal displacement reactions. Now that is we are going to discuss non-metal. What is, do you mean by non-metal? Means non-metal is displaced from its compound or from its solution. The very important thing that here normally hydrogen has been replaced, and sometimes it is observed the oxygen has been replaced, or some halogen also replaced, depending on the oxidizing property of the. So here one example, that is sodium plus H2O. What will going to happen? What is going to happen? Now this has, it is observed that 2, 2. So you can say this is balance equation now. 2 sodium, 2 sodium. You have to give 2. So what is going to happen? Okay. Now it is okay. So this is the, you can say sodium displaced hydrogen from the water and it is in the cold condition. There is no need to give any heat. So sodium is very active metal. But for a non-active metal, that is ferrous, Fe, for that it is required some steam water. When you put the steam water in the iron, it will displace the hydrogen from here. And zinc, you can see it is a very important reaction. From the HCl, it will also displace the hydrogen. This is also the metal displacement reaction. Another metal displacement reaction that is very important to show, that is fluorine will displace oxygen. Fluorine will displace oxygen from the H2O, and it will having this HF and oxygen that you can. So this is the balance equation. You can see the fluorine displaces oxygen from the water because fluorine has a very high oxidizing power, so it can accept the electron, and here fluorine acts as an oxidizing agent, but here all this metal acts as a reducing agent. That you can see fluorine has 0 oxidation number at -1, means it is reduced, means it is an oxidizing agent. It oxidizes the H2O oxygen to produce this. So what is going to happen? This is the oxidation process. This is when H2 is converted into the oxygen. At that time the oxygen is oxidized to oxygen element, that you can see -2. This is oxidation process, and this is the reduction process. The oxidation agent is fluorine. In the same way, you can see the chlorine will displace the bromine from its compound, that you can also observe this. And similar way that bromine can displace the iodine from this compound. So this is all the non-metal displacement reactions. So we understand the 3 type of reaction. Then we are going to understand another very important type of reaction, that is the disproportionate reactions. We are going to discuss another very important, that is 4th number reaction, that is disproportionation reaction. Disproportionation reaction, that is very, very important. Here in this reaction, what we will observe, the reacting species will have one element which is simultaneously being oxidized and reduced, and that is only being possible. That element in this reacting species will have at least 3 oxidation state. So this reaction will not going to show by each and every element. It will show by those elements in a compound which have the 3 oxidation state. So first, 3 oxidation state. 3 oxidation state. When the 3 oxidation state, and it will present, not only that, another condition, that the oxidation state at the intermediate state. Oxidation state at intermediate stage. At the intermediate state. So we see these 2 conditions has to be fulfilled by the elements, then only it will going to show the disproportional reactions. One example can clear you, that is the H2O2, when it is going to produce the H2O and O2, it will going to see the disproportional reaction. Here oxygen we know that it can be oxidation number can be 0, oxidation can be -1, oxidation number can be -2, oxidation number can be half. So various types of oxidation state can see. Here in the H2O2, the oxidation state of this oxygen is an intermediate state. And the intermediate state that it can increase or it can decrease. So you can see here it is been increased when it is produced the elemental oxygen gas. It will going to happen. This is in the gaseous state and this is in your liquid state and it is in the liquid state. So what it is going to happen that -1 is increased to this. This means here it is being oxidized. At the same time, in the H2, this oxidation number decreases. So you will say this is reduced. This is reduced and this is oxidized. So this element present in the intermediate -1 oxidation state, it can increase and it can decrease. What you see that when it produce the oxygen, it increases. When it produces H2, it decreases. So this is a very simple example of this disproportional reaction. Another reaction, this reaction will show by the phosphorus, by the sulfur, by the chlorine, bromine, iodine. But fluorine cannot able to show this disproportional reaction because it is only have one oxidation state, that is the -1. So another reaction that we are going to discuss, that is phosphorus, P4 plus OH. OH means that is it when it act with the in presence of alkali, we say OH and it will going to produce the PH3 and H2PO2 ions. So here you can see phosphorus having the oxidation state 0, it is decreases to -3, whereas here in the H2PO2 it is +1. So you can see this component, this phosphorus is both reduced and it is both oxidized. So it will show this disproportional reaction. Now we can see for the chlorine also. Chlorine plus OH minus, it will going to produce the Cl minus plus ClO minus plus H2. So you can see here, this is a chlorine at 0 oxidation state, it is decreasing here, and here you can say it is increasing. So this is thus this is a disproportional reaction is there. So now one question is given. You have been given this ion, this and this. You have to see which of these species will going to show the disproportional reaction and which is not going to show the disproportional reaction. Here you can see the ClO minus, these ions have the oxidation number is +1, whereas this is oxidation number is +3 and this will be +5 and this will be +7. So what is there? This here the oxidation number of chlorine can increase or decrease. Here also oxidation number can increase or decrease. Here also oxidation number increase or decrease. But in this case there is a no chance because the oxidation number of the chlorine maximum, that is +7. So it will only decrease, not increase. So at that case what we find that it will not show the disproportional reactions. Understand the 4 types of redox reaction. One is combination reaction, then the composition reaction, then we have discussed the displacement and disproportional redox reactions. And what are the uses of the redox reaction? Let us have some brief of this. First redox reaction is used, that is for extraction of the metal. Extraction of metal. Number one. Number two, it can be used for the photosynthesis. Number third, electrochemical cells. Number four, for energy. Number five, for producing chemical. And number six, that is the analytical process. So we can understand how important redox reaction is. Extraction of metal, then photosynthesis. We know the plant able to grow the foods, grow the different things by the use of the photosynthesis, and this is also a application of the redox reaction. Example of the redox reaction. Photochemical cell, that we will discuss in detail in the electrochemistry chapter in the class 12, and it will produce the energy. When we take any foods, that foods is being energized with these redox reactions. And producing chemicals, the caustic soda, chlorine, bromine, that is also being produced by this. So this is all for the, in brief, the uses of the redox reaction. So that is all for today's lecture. In this lecture we have discussed these types of redox reaction and these uses. Thank you very much for watching, and I hope all the points have been clear to you. If there is any doubts, you can comment in the comment sections. If you like this video, you can share to your friends. Thank you very much for watching. Next, we will discuss another very important topic in this redox reaction chapter. Thank you very much for watching.